If you're ready to harness the power of your communications data, blast off with Nylas today.
Hey, Blag, it's been a minute. How are you doing today?
I'm doing fine, Ash. Thank you. How are you?
Yeah, doing good, thanks. So today I'm going to be almost entirely in the learner seat here, and you're going to be walking us through a topic you've had cooking for a little bit now, introducing us to functional programming.
Yep, exactly. So let me share my slides. So yes, this is a small introduction to functional programming. It's obviously small because, functional programming is pretty huge. So we're going to talk about a little bit of Erlang and Haskell. So Haskell is a purely functional programming language that first appeared on the 90s, so 32 years ago. And then Erlang, which appeared on 36 years ago, is concurrent and functional. And
Cool.
they both can be installed using Brew.
Nice. So both of these, like you've got a couple of languages listed here, but it's my understanding is that we can use these languages as almost like pure examples, but for example, like in JavaScript, we can also program in a functional manner as well.
Yes, exactly. Even on Python, you can use some aspects of functional programming.
Cool.
But these two are kind of more pure. Especially Haskell is purely functional for some weird reason. So let's start to deep dive of what makes functional programming special or different. So first of all, variables are immutable. So once you create them, you cannot change their values. So variables are not variable, which is kind of funny. So if we need to change the value of a variable, we need to create a new variable and then put the value in there, right? That's why functions are very important, because we can pass a value to a variable, that is inside a function, and then we can change the value inside the function. So we don't actually change the real estate of the variable. And that's kind of hard at first, but then you get used to it. And as a funny thing, there's one language called Miranda, which doesn't even have variables. So even if you could change the value, you can, because there are no variables.
That's really interesting. Well, and I think, again, kind of not to bring everything back to JavaScript, but that's my comfort zone. JavaScript developers will certainly be familiar with topics around immutability, because that's been a big topic in the JavaScript world for quite a while now. And particularly, if you do anything front end related with React, the whole idea is that you don't, generally speaking, you're not overriding variables, but just as you said, you're making copies and making your edits into new variables instead.
Yeah, exactly. So it's kind of like a best practice. We also have pattern matching, which allow us to create the same function, but passing different values. So you can have a function called sum, for example, which is going to sum two values. But then you can also have sum, which is going to sum 3 values or no values. So instead of creating different functions, or having a function that have an if to see whatever you're passing as parameters, you simply call the same function, and depending on the parameters, it's going to behave differently. So we're going to see an example at the end, but it's very interesting. We also have anonymous functions, or lambdas, which we know we can use in JavaScript, which you can use on Python. So anonymous function doesn't have a name. They replace functions that are not called very often. Obviously, it reduces the length of the code, and they're faster than regular functions, because usually you declare a function and then you need to call it. With anonymous function, they're mostly inline. So you just can call them in one line and do exactly the same thing. So they're pretty useful. Then we have closures. So a closure is a function inside a function that gets access to its parent's function variables, which is kind of like a mumble. But it helps to maintain data encapsulation. Also, data is persistent. And actually, Clojure, which is a language based on the Java virtual machine, got its name from closures. So closures, and then you have Clojure, which is a nice programming language.
With a J, that's right.
Yes,
yeah.
Exactly. Then we have list comprehensions, because actually lists are the most used type in functional programming. Usually you don't have like arrays or anything like that. You have list. And I think that comes from Lisp, actually, with everything was like list and parentheses. Because also there are no loop constructs. So you don't have like a for, like a while, things like that. Usually you use recursion. So list help with that. And we can use list comprehensions, which kind of like replaces a loop. So we can go through a list using list comprehensions instead of a loop. And we can apply a function to each of the elements of a list. So we're going to see an example also on that. And recursion is one of the most important things on functional programming, because it allows us to call or make the function call itself multiple times. So we use it in conjunction with pattern matching, because we call the function several times, and at some point it needs to end, right? So we can say that if we have two parameters, it's going to call the function, but once it doesn't have parameters, it's like, okay, stop it. There you go. And then you return the result, right? That also helps because we don't have loops. So we use recursion or list comprehensions. It makes the code work shorter. And they are not exactly as fast as loops. So it actually depends on the language we're using. But it really helps. I mean, there are some things that you can build pretty easily using recursion. So I don't know if you want anything to add before I jump into the source code.
No, at this point, I'm just like super curious to see what we're going to be looking at. I think it's particularly like this. What were you calling them? List comprehensions. I think I get the idea, but I'm really curious to see what they look like in practice.
Sure. I might need to open a new example, but that's fine. So let me first, let me share this one. So this one is actually for pattern matching. So this is a code coding Erlang. So here we have a module called greetings, which is going to have a method called greet, which is going to take two parameters. So here you can see that we're calling the same method. So we have greet, greet, and greet. It's the same method. But here is taking a constant, male, and a name. Here is taking female and a name. And here is taking whatever else, which is not male or female, and also a name. So the idea here is that if I call greet with male and then a name, it's going to say, good morning, Mr., and the name. If I call it using female, it's going to say, good morning, Mrs., and the name. And if I call it with anything else, it's going to say, good morning, who knows, and the name. So instead of having like greet and going like, if you receive male, do this, if you receive female, do this, we just can declare the same function name, but just using different parameters. So I could actually have like another one, say another greet, male, age, and name. And Erlang is going to be smart enough to actually call the function that it needs to call depending on the parameters. So the number of parameters and the name of the parameters.
So can I ask there, like when you have those first parameters, and there's three different ones, male, female, and then underscore, which presumably means like lack of any information. Like how are you passing that in? I'm curious to see what these calls look like.
Yeah, you're gonna see it in a second. Let me just go here and go to the Erlang code. So first we need to compile the source code. So erc, this one is greetings, URL. So now that it's compiled, I can call the Erlang compiler. And here I'm gonna say greetings that, so the name of the module greetings, greet is gonna be the function. So here I can say, for example, male, and here pass a name, for example, Ash. And finish it with a period, which in Erlang, everything finishes with a period.
Okay.
It's going to say, good morning, Mr. Ash.
Oh, that's interesting. So that's really curious. So what is that first parameter in Erlang called then? Because that looks to me like it would be, again, with my JavaScript brain on, that looks like a variable.
Yeah, so the first one would be more like a constant.
Mm.
So it's like, I think it's coming like an atomic value, which is not exactly a variable, but it's more like a immutable string, something like that.
And it doesn't require quotes of any kind. Very interesting.
Yeah, exactly. So here I can pass a field model name. I can say good morning, Mrs. Neely. Or if I say, for example, not male, not female, but I said, for example, dog, and I put the name of my dog, it's going to say, good morning, who knows, and then the name of the dog.
Okay, interesting. So like on line 8 in your code there, just this is like more Erlang syntax questions than anything, but is that underscore? Is that like some kind of special keyword that's known to be a placeholder, or what is the underscore doing there?
Yeah, this is what it's for a string.
Oh, no. On line 8, do you see, it looks to me like,
This.
Yeah,
So this is, I think, like whatever that is not either male or female. It's like a placeholder, like a
the wild card. Yeah,
Yes.
yeah. Okay.
So you can put whatever you want in there. Then the other example is a factorial in Haskell. So you see here, we're declaring the function factorial. And this one is going to receive an int, and it's going to return an int, right?
Mhm.
So here, we call in factorial, we're passing 0, and we're returning 1, which means that if we call the function factorial passing a 0, it's going to instantly return 1. If we call factorial with any other number, which is not 0, let's say 5, for example, is what it's going to do. It's going to say 5 multiplied by factorial n minus 1. So it's going to say, we're going to pass here 5, and then we're going to call factorial again, but passing 4. So here it's going to be 4. It's going to say 4 multiplied 3, 2, 1, until n becomes 0, which is going to return 1. So here we're using recursion. So it's calling factorial all over again until the number that we're passing as an input is 0. And then it's going to make it end. So it's not exactly as a loop that never going to end. I mean, you don't need a break or anything. You just need to say, if the input is 0, then return 1.
Although the line 2, of course, is really important there if you do want it to end. Otherwise, I guess it would just keep going.
Yes, if I don't put this, yeah, it's going to be looping or recurring until everything breaks, right? Because at some point, like the heap is going to be overflowing and everything is going to go down. So here we're going to call the Haskell compiler, and we're going to load this source code. So that L, we're going to say factorial. It's loaded. So then I can say factorial, for example, 10. It's going to return a huge number. If I put 5, it's going to be 120. If I set 0, it's going to return 1. So you see how that works.
Yeah.
It's going to be calling itself until this input parameter becomes 0, and then it's going to stop.
Cool. I mean, and so like the idea there too, I guess, is that like, you're not really doing much in terms of like declaring variables here and there in a function like that. Instead, you're passing an input, and it's doing recursive calls until it gets the output that you need. But that's really it. There's not, I guess, like, I don't know if you would call it stateless, but like that notion of not having these sort of like various variables that you're kind of juggling around inside of the code.
Mm-hmm. Yes, exactly. So this one is, for example, for list comprehensions. Here we're going to do, if we're just going to receive a list as an input. So we're going to say that each of the elements of the list is going to be X. So what we're gonna do is just gonna grab this x, we're gonna multiply it by 2, and then add 10. So if we call this list comprehensions, and then I pass like 1, 2, 3, 4, 5, so just a list. And I think it's gonna start. 1, 2, 3, 4, 5. Hope I don't make any mistake here. Uh-huh. Okay, that happens when you do slice things.
Yeah, it's all good. You got me. You got me on the edge of my seat though, because like this is. I'm hoping to see a little bit of what these list comprehensions look like.
Yeah. Let me see. I think I said this. It should be start, and then it should here pass the list. And I don't. That's the problem when you do multiple languages, that you tend to forget how to make them work. Okay, so let me just a tiny second, so I can go back.
You have the answer somewhere. Yeah, well, I think we can all take a second to let you bounce back and forth between Erlang and Haskell, which is something most of us are not doing on our Wednesday morning.
Yeah. Oh, I see. I see what I did wrong. It was perfect. I just needed to put it like in between parentheses. So that was my mistake. So, okay, list comprehensions. Start. Yeah, because it's actually a parameter, so I just cannot pass it like that.
Okay.
But
Yeah, I didn't even want to attempt to help you there because I look at the syntax of these languages and they're so terse anyways.
And there you go. So
Okay.
it's going to grab 1. It's going to multiply it by 2 and then add 10. So 12. 2, 14, 316, 418, and 520.
Uh-huh. Okay. So I think I understand what the first half of, so on line 5 there, you've got like the first half of whatever that is. What is this X and then the arrow pointing back and then list? Is there any way you can explain that?
Sure. So here list is going to be this list, right? Which is the parameter. Here is saying assign each of the elements to X. So it's going to assign 1, then it's going to assign 2, 3, 4, and 5. So for each of the elements, grab that value, multiply it by 2, and then sum 10.
Okay.
It's going to kind of like loop it.
And that middle thing there, I guess that may be one of the things does that not mean or?
No, in this example, doesn't mean or. So this is kind of like separating. So this is going to say, like, grab each of the elements, put it inside X, and then here it's going to say what you need to do. And this is actually kind of similar, like you can do on Ruby. So on Ruby, you can have like a list, and then you can say each, and then you can say in brackets X, for example.
Yeah.
And then X is going to have the value of each of the elements of the list. So here you could say something like this, right? So X, 2 plus 10. And actually here puts. So that would be kind of the same. But
Got
it's
it.
like a different syntax, just of doing the same. And this is kind of like a separator between the operation and between grabbing each of the elements of the list.
Okay, really cool. And I just like I'm staring at this, thinking like I'm suddenly a lot more, let's say, curious about this kind of language than I think I have been before. The syntax is clearly extremely terse, but my guess is that once you get good at it, you can move pretty quickly.
Once you know how it works, it's not really that hard. I mean, probably Haskell might be a little bit more intimidating, I guess. But here, for example, you have a lambda, which is using map, just like in JavaScript. Here, this symbol, it's saying, okay, this is an anonymous function. So it's not that hard. And actually, this is going to do exactly the same as the other one. So
Okay.
this one is going to go through a list. It's going to multiply it by 2, and then some 10. But this is kind of like a different way, right? That's kind of like a longer form of doing exactly the same.
So on line 8 there, just to be clear, for someone like me, that map, is that a map in that like you're iterating through a list?
Exactly.
Or is it okay, so it's not like the data structure map. Okay.
No, it's just iterating through a list. So here it's going to say like you capture lambdas and then you're receiving a list. So you want to map each of the elements of the list. So that is going to go here into this anonymous function. So the XS is going to be each of the elements of the list.
Okay. And oh, I see. So this is the same thing you just did in the other language.
Mm-hmm.
Okay. Interesting.
Yeah. Just different ways to do exactly the same thing.
Okay.
Mm-hmm.
Which is like, that's your, I guess kind of wrapping up here then, like that's kind of like how you, as someone who kind of like loves to learn different programming languages, actually, that's your approach, isn't it? Like you have like a handful of things that sort of you've decided you want to know how to do in any given language, and then you go through and implement it. So that way, like, it's just, you kind of know, okay, here are the inputs and here's the expected output. Am I able to do it?
Yeah, exactly. Once you have like a set of things that you want to do, and you grab a new language, it's like you kind of know what to expect as a result. So it makes it easier to learn different programming languages, different paradigms, and everything.
Yeah.
And stay tuned, because on upcoming live streams, we're going to talk a little bit about logic programming and also stack-oriented programming.
Stack-oriented programming. All right.
More weird sometimes.
Jeez. Well, this is really cool. So I just maybe one thing that kind of to close out. Do you have any thoughts on like when is it a good idea to reach for functional programming, or what are some just like general kind of use cases that like why might a developer opt for this?
So the thing mostly, I think, functional programming kind of like opens your mind to different things. Sometimes you're going to use it, sometimes you don't. It really depends. But it really makes you think. So sometimes you need to tackle a certain problem in a complete different way. You need to like really, really think about it. And that makes you, I feel, a better programmer for sure.
Okay, interesting. That's fair enough. Yeah, I think that in a world where to get most things accomplished, I need to do like list comprehensions and recursion. Yeah, I think I'd be doing a lot more thinking, that's for sure. But this is a really cool sort of like getting started on a couple of languages that, I think, well, I'll say at least for someone like myself, it sometimes feels a little intimidating, and to kind of get started or really understand what you would do with it. But yeah, that kind of whirlwind tour through the concepts of functional programming with some examples was super helpful.
Yeah, and it's good to know. I mean, I don't think many people are going to actually work like doing Haskell or Erlang, but I mean, knowing the basics is pretty good for sure.
Okay, cool. Do you have a blog post or something like that that is associated with this?
Yeah, yes, of course. I don't have it handy, so let me just look real quick.
The blog URL.
Yeah, but it's published on the Nylas blog.
Yeah.
Just let me, here is, quickly just share the link. And here is. So just look for a small introduction to functional programming or just functional programming on the Nylas blog, and you're going to be able to read all the examples, some in Haskell, some in Erlang, more explanations, and just let us know if you get stuck or anything.
That's great. Yeah, you can read the blog post, try it out, and not get interrupted with dumb questions from me. So this is really cool. Thanks, Blag, for this quick introduction into all this stuff. And yeah, thanks for throwing that up too. We all these live streams, they go up on YouTube. I don't even know. We're in the 20-somethings.
27, which is a great accomplishment.
Yeah, 27. Okay, cool. So
Yeah.
we're at 27 of these things, and a lot of times we look at topics related to Nylas about sending, or managing email contacts and calendar through our universal API. But there are times where we just want to step back and talk about some basic programming concepts like what we did today. So go check out the YouTube channel. There's a whole playlist there of the DevRel team at Nylas talking you through a bunch of different cool things you can do with our APIs, and in this case, beyond that.
Yep. So thank you very much for watching, and see you on the next live stream.
Bye.
Thank you, Ash. Bye.